1, here we go. So, really quickly, I want to go back over some things that maybe some of you missed first term and caused you problems with your grade. So, first of all, if I miss a day and I'm sick, what do? Don't come back the next day and say, Mrs. Howell, what did we do in class? Because right here in your Canvas, under daily schedule, if you click on it, it tells you what we did. And I put up the videos from class so you can listen again, even if you're lost in class, you can go back and listen to what we did in class. Okay? What quiz you were supposed to do is hot linked on the day. What work you were supposed to turn in is hot linked on the day. So everything you need is that on that day. Now, if you happen to be absent and we did a lab, this is a big one. If you're absent and we did a lab, you need to email me as fast as you can and say, Mrs. Howe, please don't put the lab down. Because we've got like 4 different chemistry classes rolling, and we do 4 different chemistry labs for the 4 different chemistry classes, and we're taking down and putting up labs constantly. So if you don't tell me that you need that lab, it might be down before the time you come to get it fixed. Okay, and then it's a 0, done. Or you're trying to do as much pre-lab and post-lab without doing the data in the center to try and get some points. Okay, so make sure you're emailing me that. Today we are going to be working on, we've just done quiz 4.1. We're going to work on introduction to the unit 4. We're going to do a Nearpod. We're going to talk about ionic bonds, and we're going to hand in daily work 4.1. Last period, almost 75% of the kids were able to be done, handed in their thing by uploading it by the iPads or whatever, and they had 10-15 minutes left over. So if you stay with me and you understand what we're doing, that would be awesome. Okay, so here we go. I don't think I put it on the right side. It'll be just 10 seconds more. There we go. So we are starting into bonding. And these are all the James bonds, so you can help remember. The first type of bond that we're talking about is ionic bonding. So it's all about the James bond. It's all about them. Okay? This is sort of funny because this is a bond too. Sodium chloride here. Haha, it's a salt. I know. Okay, so we're going to review the periodic trends today, talk about ionic bonding, and do a Nearpod. So let's go ahead and start talking. The first thing that's not on your notes is talking about atomic trends as far as the size. If we understand the size, then the other trends we're going to talk about make a lot more sense. The biggest element on the periodic table as far as atomic radius is francium. So francium would be even underneath rubidium here. It's the biggest. And that's because as we go down a row, we add a shell, right? We add a shell out. Remember we had this 1, 2, 3. That was how many shells out from the nucleus it was. As we come down a row, we add a shell. But we only add 1 proton to the nucleus. And so this 1 proton in the nucleus has to go through all these shells to try and pull in that 1 electron on the outside. And it doesn't really have enough strength to make it through. So that electron on the outside sort of goes as far away as it can. As we go across the row, you can watch and see and look and see how it gets smaller and smaller and smaller. That's because I'm adding more protons to the nucleus, but I'm not changing what level out it is from the nucleus. I'm just adding more electrons out here. So there's more positive pulling in those negatives on that outer shell. Then when I go to the next row, I add another shell, which makes it fatter, and I only have 1 in the out. Okay, does that make sense? So my smallest on the periodic table is helium. My largest is francium. Okay? So that is just atomic size. Everybody okay with that? Understand it? Okay, so now we're going to add into that what is electronegativity. Electronegativity is basically something's ability to attract something else. Okay, how badly does it want it? It's like how much work am I willing to do to get that prom dress for prom, or am I just going to borrow somebody's? How much effort do I need to put in? if the garden will grow food and I don't have to weed it, do I really need to weed it? Kind of thing. So how much effort am I going to put in to get this? So I'm falling for him. He's so strong. So how much pull does this person have? Okay, so we're going to define a little bit more. On the periodic table, francium has the lowest electronegativity. What did I just say about francium? He was the biggest. Well, if he's the biggest, does he really want any more electrons? No. So he's like, I don't care if I have another electron or not. I'm so big as it is. But fluorine is one away from being a noble gas like neon, and it's small. It only has 2 layers. And so it really, 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 really wants one more electron. Because then I can be a noble gas. And I'm a noble, then I get to live in the castle, and I get to do all the things with a nobleman. Okay? So I want to be a noble gas. I'm just so close. If they just let me in the door, I just need that extra electron. So they really badly want that electron. Okay? What about the noble gases? They're not on this list. How badly do they want an electron? Why? They're already nobles. Why would I need anything more? I've got the kingdom, right? I don't need any more. Okay? So, trending from francium lowest to fluorine highest. Noble gases don't have an electronegativity. That's important to know. So write it down, whatever you need to do to remember that. Francium lowest, fluorine highest, noble gases no electronegativity. 0. The other thing that we need to know about is ionization energy. So francium lowest, fluorine highest, none in the noble gases. Ionization energy is like, how much energy is it going to take me to take something away, and this something for an atom is an electron. So I'm thinking, what thing do you really want? How much energy are you going to put in to pull it away from somebody else? Like my sister had this really cool pair of jeans. We both fit in. I really, really want them. How much am I willing to pay her or go and do for her to get those jeans? Okay? Or my brother really has this cool car and I really like to use it for prom, but how much am I willing to actually give him or do for him so he'll let me use it? Okay? So ionization energy is how much does it take to get one electron away? Now think about this. What area on the periodic table is going to be the hardest to take one electron away from? The noble gases. Why? Because they are where they want to be, right? What about the next column over, fluorine's column? Do you think they'll want to give away? No. Absolutely not. I don't want to give it away. I want to get one. So they're going to be really high too, but noble gases are going to be the highest because I've already reached this state. Don't you even think about demoting me down to peasantry, right? But if we look at these guys over here, lithium's column, do they want to gain an electron or give one away? They're trying to give one away, so the ionization energy, the amount of energy I have to do to pull away an electron from this column, really low. Because if I pull one away from cesium, it becomes like the noble gas xenon. Yes, I've made it. You can take this electron, right? And you can take it. I will pay you to take it, right? Okay, so ionization energy, amount of energy it takes to take something, an electron away. First ionization, first electron. Always on the second ionization it will go up. Why? Because it's not just one ionization. We can take 2 electrons or 3 electrons or 4 electrons. Why would ionization energy go up all the time after the first one? Why? What happened to the center of the atom? We have our protons. Do we do anything with our protons? No. So I still have the same number of protons because that's my identity. Right? But I've taken these electrons away. And because I've taken the electrons away, I now have more positive charge than I have negative. Right? would like you to grab your stuff, and I want you to go sit up right there. I want you to grab your stuff and sit right here. And that's where you'll sit for the rest of the term, unless I move you again to start. Sorry about that. Sometimes we have to play elementary school, even though we're in high school. Unfortunately, some can't handle it. Okay, so going forward here, if we look at the actual ionization energy, notice the highs are the noble gases. The lows are lithium's columns. There's some little bumps in that in between, and we could go and talk about that, but all we need to know is noble gases are high, and the other side is low. Okay, so as we look at ionization energy, this is the trend. Okay, right there. Okay, I need you to open up your canvas on the left-hand side, down at the bottom of all the things that you can do from home to assignments. There's Nearpod. Go ahead and click on Nearpod. Okay, once you click on Nearpod, this is the code that you need to get in. On the left-hand side, under where it says Home and Discussion Grade, it's the last one out at the bottom, Nearpod. And then it says Join a Session, and you put that code in. Everybody found it? So if you're listening to this online, you're going to do this, and then come back. I cannot stop the video, so you're going to have to advance it. So it's been taking us about 10 minutes, 5 to 10 minutes to do this. So go ahead and start it. So just go back up to the top. Home, wherever you are, home. So the very top of this. Yep. Your pod right there. Okay, so you're getting into Nearpod. The code is capital M, capital C, capital N, capital Q, capital V. And this is on your own. Try your best. This is recapping what we've just been talking about. Do your best. When you are done, there'll be a little arrow on the upper right-hand side that is black. You will click on that and say exit, and it will send it to me. If you need help, let me know. Yes, you may use your notes. Oh, sorry.
On this, like, can we use the, like, you said it's like the prom stuff?
You can, yeah, you can, whatever you can in your head, what it's like. This is, it doesn't have to be my specific example. You can do something else. Electronegativity is like, what is it like to you? What would it be like to you? Yes. Ooh. Dang it. Okay, just watch his real quick, and then hopefully in a day or two you'll be able to go back and do it. And sorry, darn it. Huh? She switched from C down, so she'll just watch you if that's okay, and just sort of see what's going on. Hopefully they'll get that fixed. They've been having problems with it Encore and Canvas right now, so let me know if you haven't by the next time. Okay. Did you pick up one of these? Okay.
Electronegativity, would it be like this column?
No, remember it always goes from Francium to fluorine. Francium being the lowest, this is the highest. And you can actually draw on the periodic table. Yep. When you get to the periodic table, you can actually draw right on it, guys. You're showing me the trend.
So it goes from small to big as well, right here, going side to side.
So what are we trying to do?
small to big. We're showing an example of electronegativity.
Oh, electronegativity is small to big over here.
Yeah, that's right.
So we're just supposed to mark the...
Yeah, you're just drawing it like an arrow and labeling that arrow, telling me where it's going from. So which one has the highest electronegativity on the periodic table?
Oh, so it'd be this one.
Nope, francium. So this is the highest, that's the lowest. So francium's the lowest, fluorine's the highest. So you can draw an arrow.
Francium?
Francium's down below over here, we talked about.
Oh, right here.
Yep.
It's
You
off
just
the-
draw an arrow from there up to fluorine and then say increasing. That's all it's asking you to do. Or you can draw an arrow from fluorine to francium and say decreasing.
Wait, where's fluorine? That's what I'm confused. Oh, okay, sorry.
Mm-hmm. Doing okay?
Yeah, the stupid part is annoying.
Make sure after you draw your arrow on the periodic table, you tell me if it's increasing or decreasing the way you did your arrow, whether it be ionic size or ionization or electronegativity or whatever. Remember, when you get to the very end of the Nearpod, you want to use that little arrow with the black pointing down, click on it and exit. And then if you haven't finished your quiz, you can go back and do your quiz, or if you didn't get 100% on your quiz until we all come together.
How much Oh,
Okay, keep going. So ionization energy is like, so ionization, how much energy it would take me to take something I really want from somebody else.
So can I just say for...
You can, whatever it makes for you. So ionization energy is like,
pulling...
okay,
I mean, I get...
how much energy you need to put out to get something you really want.
Oh.
So something you really want, how much energy would you be willing to put out to get it? Yes, ma'am. So which way? Are you going up or down? So is this, pull this down so you can see what you're being asked real quick. Oh, this is electronegativity. So which one's highest, francium or fluorine? Which one? Nope, fluorine. Fluorine's the highest. So you need to write highest up here and lowest down here. Okay. And if you'll change that color font so I can see it, because I didn't even see that. You doing okay? Got it? Mm-hmm. Awesome. Did you do a quiz?
I started it on my phone,
Okay, yep, keep going. Go back and get it done. While we're waiting for everybody else, make sure we get our quiz done. And if you didn't get 100%, go back and do it again. Yes?
So you know how it's like this?
Mm-hmm.
Like, how do
Those
you...
are the noble gases.
Mm-hmm.
Okay, so that's the high over here is noble gases. The low was over here.
Mm-hmm.
For francium
So-
being the
oh.
lowest, helium being the highest.
Oh, so this one's just... Wait.
You just do another arrow. So if you click down off here, or sorry, click this up, then you can see it. Mm-hmm. Yep. Yep. They actually trend the same. Okay, remember when you get back to the main screen when it says Nearpod, you need to bring that arrow down, that black arrow, and it says exit, then it will report to me. If you forget to exit, it won't report to me. You want it to report. You don't like Nearpod, huh? Oh.
Well, I don't like drawing on it. It's difficult. Very, very difficult. So do you just submit?
There's a little black arrow at the top. You're going to click on it and exit Nearpod, and then it will record it. You just exit Nearpod, and it will submit to me. Yes, ma'am.
Can I use the whole class?
Yes, quickly. About 2 minutes and we'll start. Okay, go about 2 minutes and we're going to come back together. So quickly in 2 minutes, finish whatever you need to and we'll come back together.
For some reason I can't read like the question.
That is really weird.
Yeah.
Oh, there is a submit button for some of you, so submit it and then to get out of it, you do that. If we exit. It's really weird. Because it's almost like, I wonder. I think it was enlarged too much.
Click down arrow. No, the wrong.
Okay, there you go. Yeah, submit and then do the arrow like I told you, sorry. That's fine. I think most of them, by the time you get to that point, that's where it did. Okay, about another minute, guys, we'll come back together. So you'll want a couple different colored pencils. So if you want to pick a couple colored pencils and get them, if they're not sharpened, get them sharpened. That would be a good idea. You need about 3. So 3 different colors. It doesn't really matter what colors. But it would be helpful for this next part to have 3 different colored pencils. Okay, 30 more seconds and then back with me. We're going to be on the next page in your notes. So if you'll get there.
Where's the Wikipedia on the other table?
Where's the what? Palladium. It's all right. I've been here a lot more. Okay, we ready to come back at me? In 3, 2, and 1. Everybody back up at me. If you need to go back to the Nearpod, we will have some time at the end that you can have some to go back to that, and I'll put the code back on. All right, so we are starting with bonding and what's going on with it. So, what's involved? Electrons. We've been working with electrons in the last unit. We're now working with them in bonding. Well, James Bond, he doesn't like to share, so this is a give and take kind of thing. You will give it, he will take it. Okay? So we're moving electrons from one atom to another atom. The example that you've been given on your notes is sodium chloride. And just like at the beginning, sodium chloride's a salt. Okay? It actually is taking one from sodium and putting it to chlorine. So we were just working with electronegativity, right? Which one of these, sodium or chlorine, has the highest electronegativity? Which one? Chlorine. Chlorine is right here, right? It's one away from being a noble gas. So it wants the electron. Where's sodium? Clear over here on this other side. And what does it want to do? Get rid of it. That's right. So in doing that, sodium becomes positive because it made it to the noble gas. Chlorine becomes negative because it gained one more, right? Okay, so when we have ionic bonds, they actually line up positive, negative, positive, negative. And if you hit an ionic substance with a hammer, it shatters. Why would it shatter? Anybody have any ideas? Well, let's look. If I hit it with a hammer, this row would go down one. And what does that do? It puts a negative next to a negative, a positive next to a positive. What do we know about same charges? They repel. So that's why it shatters. Okay? All right, so I like this cartoon. It says, perhaps one of you gentlemen would mind telling me just what is outside the window that you find so attractive. So Inside we have metal ions that have given up electrons and become positive. Outside, what do we have? Anions that have gained electrons. So we have in ionic bonds what's called electrostatic attraction. It's not really like a handshake bond where they actually hold something together, but it's like opposites attract. Sort of like the bad girl is always going to attract the good guy, and the good guy is always going to attract the bad girl, kind of thing, you know, back and forth like that. I don't know why it is, but it just is. Okay, so let's do some of these. Now, it breaks it down into 3 things, so you guys help keep me on track, because I just do it all at once. So I'm going to be talking through what you need to write down and drawing too. So you got your 3 colored pencils? Let's pick one up for sodium. Sodium is Na. If I were to do the Lewis dot for sodium, what would it be? 1. Why did you get 1? Because it's over there. Somebody help her. Why do we just have 1? First column. Yeah. So 1 dot first column. Okay, pick up another color. This is in where it says example between bonding. Draw the Lewis dot for each element. Okay, so this is sodium. And then we do chlorine. Chlorine has how many? 7. How did I get that? Okay, going on that row to get to chlorine, how many do I pass in the first 2 columns or the last 6 to get to it? And I go 7. So we put it in 1, 2, 3, 4, 5, 6, 7, right? Okay, pick your 3rd color up. This is the next thing that you're answering. Which one's going to give up electrons? Sodium. So sodium's going to become, if it gives up electrons, it becomes positive, and it becomes like a noble gas, but it becomes positive. What was a positive ion called? Positive cation. So it's a cation. So this one's going to become my cation. Whoops, I didn't change charges. Things. Cation. Because it gives up electrons. What's this one going to be called? Anion. Good. Because why? Gains electrons. Good. So I'm going to be actually showing this electron with that color moving over to here. Okay? Then I'm actually going to redraw this on that 3rd area and say, okay, sodium now becomes a positive. I don't have to write the 1 because if we write a positive, we know it's 1. Okay? And chlorine, I'm going to put right next to it, but I'm also going to show the 8 electrons around it becomes a negative, and they are electrostatically bonded. Yes? On number 2, show the arrow transfer. Okay. So if you want to show it in the one you've already drawn, you can, and then just put an arrow down. That's fine. And then number 3 is draw the new formed ions. So that's what you would do down at the bottom. So I sort of combined 1 and 2. Huh? And 3 is this bottom one. 3 is this part. Just that part. Okay. So let's do another one over here. Again, grab a color. It doesn't really matter which one. We're going to do calcium. What's the Lewis dot for calcium? Find calcium. It's number 20 on the periodic table. How many? 2 dots. How do I put those 2 dots on? 1 on each side. Awesome. Thank you for remembering that. It is great. Okay, next one is chlorine. Chlorine we just did over there, so we know it's 7. So I'm just going to put 7 here. Now wait a minute. Calcium has 2, but chlorine only needs 1. How can I fix this? I actually need another chlorine. So I'm going to put another chlorine here. Because I need to have 2 chlorines for those other 2 electrons to go. So which one's going to be the one that gives up the electrons this time? Calcium. Calcium is going to be my cation because it's going to give up the electrons, and chlorine is going to be my anion. I'm not going to write it this time. I'm just going to show it. So this one is going to go here, and this one is going to go here. That sort of went off a little bit, but that's okay. Now, this is sort of important. See where I took those electrons from? Chlorines actually had to go to that area to get those electrons. So when I draw the formula for this, I'm going to take calcium and put it in the middle because one chlorine is going to have to be on one side and the other chlorine on the other side. Okay, so I'm going to put calcium in the middle, and since it gave off 2, it's going to become a 2 plus. Now I always say how many it gave off or took in first before the charge. Then I'm going to put one chlorine on this side with its 8 electrons around it and a negative, and one chlorine on this side with its 8 electrons and a negative around it. You don't want to put 2 positive or 2 negatives right next to each other because we just said something about that earlier. What do? They repel. But if I put opposite charge things next to each other, they attract. Okay? So if I look at where the electrons were being donated from, these chlorines had to go there to get them. Okay? All right. We okay? Can I move forward or you need to keep writing? Need to keep writing for a minute? Okay. I don't want to go too fast. I'll know you're ready when your eyeballs are looking at me. Okay, we still okay to go forward? Still have a few that aren't looking at me, so I'm assuming you're ready. Yes? Okay. All right, so this one is an example on your next page, but they sort of put it in a little bit off. So I want to go over it and have you change some things so you don't get it in your head wrong. Okay? The other teacher printed this off before I could fix it. So, magnesium. What is the Lewis dot for magnesium supposed to look like? 1 on each side. Thank you. And what else are we putting with it? Oxygen. What does oxygen look like? 1, 2, 3, 4, 5, 6, right? Okay, so then I'm going to say, I got to show where the electrons are transferring. This one is going to go here, and this one is going to go here. Now, on this one, I only have 2 elements, so I can't put an oxygen on either side of it, right? So when I go to draw what's happened over here, I'm going to say my magnesium now is what charge? Got rid of them, so positive 2, or 2 positive. We write the 2 first. And what's the oxygen? O, and I'm going to have the 8 around it. What's the charge? 2 negative. So flip it around. Okay? So make sure, see how it has that plus between it? We're just going to smash them. Okay, they're really not sharing. This is not sharing. They're attracted, but they're not sharing electrons. Okay? All right, we're going to go forward. So that plus and the minus 2 are between them. Here's another one we're just doing. Okay, lithium and oxygen. Lithium. What number is lithium on the periodic table?
3.
Number 3. Everybody found number 3? How many dots does lithium have on it? 1. Yes. Oxygen. How many dots does oxygen have? It's number 8. 6. So we're going to go 1, 2, 3, 4, 5, 6. Uh-oh. I have a problem. Somebody tell me what my problem is. I don't have enough, she says. What do I have enough of? I don't have enough lithium. Good. So I need one more lithium, right? So I'm going to put another lithium here with a dot. Okay, so then these dots, these electrons, one's going to go here and one's going to go here, right? So this is how I figure out. Since both of them are going into oxygen, I'm going to put oxygen in the middle here. And I'm going to show oxygen having all 8. And because it has all 8, what's its charge? 2 negative, good. And one lithium went here and one here, so I'm going to bring it in like this, a lithium with a plus here and a lithium with a plus here. They're not really sharing them because they've been ripped off, but that sort of gives me a sort of what the shape might be. Okay, so here's your deal. You've got the rest of this page, and that's it for today. That's the end of your homework for today. So you finish this page. Please use colors if it helps you. And you've got your Nearpod if you haven't got that done, and your quiz. And we have got a bunch of time because remember we get out later. So I think we have about 30 minutes. Okay? So good luck. I'll be wandering around if you need help. Let's get this done and get it in so you have points. So, does anybody need me to go back and give you the Nearpod code again, or did everybody finish the Nearpod? Okay, I'll put the Nearpod code on the board if you need it, because if it stays open so long, it actually kicks you out. So here's the Nearpod code. Okay.